WebAssembly is a way to run the code of your choice at near native speed in a browser or on a WebAssembly runtime. The code of your choice means you could write code in one of many languages and compile that code to WebAssembly. In this video, we'll see one of the more high-profile examples of this in action, compiling Rust code to WebAssembly and running it on a web page. Let's take a look. First, you need the Rust compiler, which we've already installed here as Rust Up Update will show us. Next, we need to set up WebAssembly as a compilation target for Rust, and this we do with the command rust up target add WASM32 unknown unknown. As you can see, I've already got that configured also. And lastly, we need the WebAssembly toolchain for Rust, which comes in the WASM pack crate, and we install that with cargo install WASM pack. Again, I have that set up ahead of time too. So in this directory, I've got a Rust project, and I've set it up using the command cargo new --lib so that it can be compiled as a library. My project has one key dependency, which is the WASM bindgen crate, and this provides interfaces between the Rust world and the WebAssembly world. The function that I'm going to expose in my Rust project to WebAssembly, it's very simple. It takes in a string, it reverses it, and returns another string that says the reverse of your string is this string. Simple enough, and it requires no dependencies other than bindgen and what's native to Rust itself. So we use the WASM bindgen annotation here to indicate that this function will be exposed through the WebAssembly interface. Now to build this into a WebAssembly module, we use the command wasm pack build --target web. And this compiles our module into a subdirectory of our project, pkg or package, and provides that with some handy pre-built JavaScript we can use to include in a web page without too much extra work. As you can probably guess from the wasm pack command, building to the web is one of many possible targets that we could use, and that's something we can explore in the future. The web page where we're going to use all this has a JavaScript module where we import our WASM package, along with the function that we've exposed and its initialization tools, which we need to get things going before we can actually work with it. The exported function gets used in an event listener for a button. We click the button, and it passes text gleaned from a field on the web page into the WebAssembly function, and then the returned results are then placed in a div. So if we open this page and type something in this text box and click the button, the results we see here are being sent to our module written in Rust and returned from it. Now obviously this is a very simplistic example, but it shows you how you can set up a bridge that can go in either direction between the web and your Rust code. Now one other thing I haven't shown with this demo is how to pass more complex objects back and forth between Rust and JavaScript through WebAssembly. Rust has a widely used crate for data serialization called serde, S-E-R-D-E, and it can be used with the WebAssembly tools in Rust to pass arbitrary data structures back and forth, but that's something that's best explored in detail in a future video. So to sum up, you can compile to WebAssembly from many languages, Rust being one of the big ones. Existing Rust code can interface with WebAssembly without too much extra work, depending on what kind of data you're passing around. And the resulting code can be set up in a web page and executed there, also fairly easily. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.